Hello students, today's topic is two-dimensional arrays. So upon the completion of the CDT, you can able to understand what is a two-dimensional arrays and how we can declare the two-dimensional array and how we can initialize, and we can able to see some of the programs upon the two-dimensional arrays. So let us discuss about the topic. The two-dimensional arrays, where we can have more than one dimensions, uh, is generally referred to as a multi-dimensional arrays. So the declaration can be, we can make an additional square brackets, something like this, to define the dimension. So this is dimension 1, this is dimension 2 size, and this is dimension 3 size, and so on. So these square brackets help us to define the dimensions basically. So the two-dimensional table, it's like a table where we can assume it like an rows and columns, which requires of a two subscript, which are rows as well as columns. So let us see an example. So this is an example. If you can consider, this is a of 3 and 4. So here it tries to create 3 rows, row 1, row 2 and row 3, and this defines you the column size, which is the column 1, column 2, column 3 and column 4, which starts with the indexes called as 0, 1, 2, 3. Similarly, the row indexes start with 0, 1 and 2. So how it can be initialized? What do you mean by initialization? Let us take an example. Like if I want to create a variable like x, so x is a declaration of a variable. If I am assigning a value like 10, so the value of 10 will be assigned to a variable called as an x. So as it is a single variable, we can initialize directly a single value. Suppose if it is a array of one dimension where we are creating some 10 variables, then we can use a flower brackets in which we can able to initialize the values separated by comma. So hence this array has 10 elements where the first 3 values are 2, 5 and 7. So this creates a memory, and in which the first index value will be 2, and the next index value will be 5, and the next index value will be 7. And what about the other indexes values? It will be initialized to 0 automatically till it reaches 10. Yes. So now for a two-dimensional array, let us see how we can do it. So it's very similar that we can include an open and close brackets, but every individual row, again we need to specify and bracket a flower braces. So this is row 1, row 2, row 3 and row 4. So similarly, we can able to create an three-dimensional array which can be visualized in something like this, where we can have an dimensions. This is first dimension, second dimension and third dimension. So visualization is something like it is a cube representation where we can have dimension 1, this is dimension 2 and dimension 3. So this type of representation is generally can be visualized as a 3 dimension. But the basic thing what we need to understand from a 2-dimensional or a 3-dimensional arrays, the memory will always be getting stored in a sequential order. So if I consider this as a memory, so as we have told that it should have an 5 columns, 1, 2, 3, 4 and 5. So this is row 1 basically, and similarly it creates an row 2 of same 1, 2, 3, 4 and 5. Okay, which is 1, 2, 3, 4 and 5. Okay, this is row 2. Then the next row, the row 3 will be again in a sequential. This is number 1, 2, 3, 4 and 5, the elements in the row 3. Okay, and the row 4 will get created and so on. If you try to understand, memory will always be getting stored in a sequential order, and never it can be stored as a tabular format internally. Okay, so that you need to keep in mind, right? So now So the multi-dimensional array parameters must specify the size after the first dimension, and we can give something like this. So when we are passing this as a parameters to a function, this we'll see later in our upcoming classes. So reflection spot, how memory is allocated to multi-dimensional array. I give some time for you to give the answer for this. Yes. So let us see the answer. Is a sequential order. Just now I stated you like the memory will always be getting stored in a sequential order. Now, lecture level problems. So we'll try to see some programs like write a C program to read a matrix with R rows and R columns, and we can print this matrix, and we can add a given two matrices of dimension mn to n and p into q, and similarly subtract two matrices and multiply two matrices. Now let us try to write some programs on this. Let us write a program on this. Nano, where we can create a matrix read.c as a program. Let me write the program. So first we'll try to create the number of rows, columns and indexes to iterate through the loop. So let us give a printf statement and ask the user to enter the number of rows and columns for matrix A. Now let us scan this values. Scanf %d comma ampersand of, first we'll try to read the rows, then we'll try to read the columns. Now let us ask the user to enter the elements, where he will be aware of just entering the element. So we need a loop which start with 0 for, and it iterates through R, means it can able to show the rows, store the it can iterate through the rows. So let us try to create a matrix in a two-dimensional, because we need to store a matrix, so where we required of a size. So basically this, let us take around a maximum size of 10 and 10, where a maximum of 100 elements can be stored. So this iterates through the number of rows, and another for loop for the column, j less than of columns j plus plus. So let us try to write a scanf to read the values now. %d. Now here ampersand of the name of the matrix A and the index values. Now let's try to store, let's try to read the number of rows. Okay. Similarly we can able to print this. So simply we can write printf elements of matrix R. Now let us try to write again a for loop for I equal to 0, I is less than of rows I plus plus. Then we can iterate it for the columns for j equal to 0, j less than of columns j plus plus. Now let us try to print this. Printf percentile d comma name of the matrix, that is matrix A of I and j. So this help us to read the element by element, and we can able to see this. And I'm closing this loop. Let us save the program, compile the program. So there are no errors. Then we can able to run this. Enter the rows, 3 rows and 3 columns. So we have to enter around 9 elements. If you see that like these elements are getting printed, but you can try to understand like this is not in a matrix format, so we need to change the representation. So simply we can go to the matrix, and here we can give a space to get a new space, and after every row we have to get a uh, a new line upon the every row. So hence I'm giving a backslash in here. So let us recompile this and run the program. So 3 elements, sorry, 3 rows and 3 columns. Elements are 1 2 3 4 5 6 7 8 and 9. Now you can able to observe like the elements are being printed like in matrix format, because we have written a backslash and a new line, a space after each element. Okay. Thank you. Remaining we'll see in our class.